All right, let's jump right in. We're looking at a big one today. The FACTS Leaderboard, a comprehensive benchmark for large language model factuality.
And this paper, it really gets to the heart of the matter for LLMs right now. I mean, we've seen these incredible leaps in reasoning, in scale, but factuality, that's still the biggest challenge. We're still fighting hallucinations.
Exactly. And the authors saw that the old benchmarks were just too, narrow. They were looking at things in isolation. So their solution is the FACTS Leaderboard, which is this really holistic evaluation suite.
It's not just another data set. It's more of a structural way of looking at the problem. It pulls together performance across 4 very different sub-leaderboards to give you one single, robust score for factuality.
And those 4 pillars are, first, FACTS Multimodal. That's vision and knowledge. Then FACTS Parametric, which is just pure memory recall.
Then FCDS Search for tool use. And finally, FACTS Grounding, version 2, which is all about sticking to the context you're given.
And the big headline, the thing that really tells you where we are right now, is that the overall FETS score, which is just the average of all 4, is still pretty low.
Worryingly low.
The best model out there, Gemini 3 Pro, only scores a 68.8. That number alone, 68.8%, it tells you everything. There's so much headroom, so much work left to do.
It's a powerful statement, isn't it? When your top-of-the-line model is getting, a C+ on a comprehensive fact test, it just confirms that getting to truly reliable AI is still a massive, massive hurdle.
So let's unpack why they even built this. I mean, what was wrong with the old benchmarks? Why did we need something new?
The core problem was compartmentalization. Everything was in its own little box. You had benchmarks that looked at one scenario, internal knowledge, so answering factoid questions from memory, closed book style.
Right.
And then you had a completely separate scenario, external knowledge. How well does a model stick to a document or an image you give it? Grounding.
But in the real world, you need both at the same time. I mean, if you're an analyst, you might upload a huge financial report. That's grounding. But then your question might require the model to connect something in that report to its general knowledge of the market.
Precisely. And we've all seen this. You get a model that's an amazing summarizer, so it's great at grounding, but then it completely falls apart on a simple memory question. Or the other way around.
So the FACTS Leaderboard forces them to be good at everything. It tests across different contexts, different modalities like text and images, and different knowledge sources, what's in the document, what's in its memory, and what it can find online.
You just can't game it by being a one-trick pony. And that final FACTS score, that average, it's a really honest look at a model's abilities. Plus, I love that they use both public and private data splits.
Oh, that's huge. The private splits, I mean. It stops people from just overfitting to the public test set, which keeps the leaderboard honest. It's all hosted on Kaggle, so it's a living benchmark.
Right. And looking at those initial results in Table 1, it's fascinating. Gemini 3 Pro is at 68.8, but then you've got GPT-5 at 61.8 and Gemini 2.5 Pro right there at 62.1.
So even the very top models are clustered together. But with these big gaps, nobody has really cracked this yet.
Not even close. And the scores inside each pillar vary a lot, which brings us to the first one, FACTS Multimodal. This is where things get really tough.
This is the integration challenge.
Yeah.
You're testing if a model can connect what it sees in an image with what it already knows about the world.
Exactly. You give it a picture of, say, an old, rare locomotive. It has to recognize the train, sure, but also maybe pull from its memory the year it was built, who manufactured it, things like that. It's connecting pixels to parameters.
The data set sounds pretty comprehensive, about 1,500 questions, covering everything from just describing what's in a picture to interpreting complex charts and graphs.
Yep. And the way they grade it, this dual verdict metric, is the real technical core here. It's incredibly strict.
Okay, tell us about that. How do the automated judges actually score a response?
So it's all based on a human-written rubric. The rubric splits the correct information into 2 buckets. Essential facts, the absolute must-haves for a good answer.
And non-essential facts, the nice-to-haves.
Exactly, the contextual details. For a model's answer to be marked accurate, it has to pass 2 completely separate verdicts.
The first one is the coverage verdict,
which is pretty simple. Did the model's response cover all of the essential facts? If the question asked for 3 things, did you get all 3?
Okay, makes sense. But the second one, the no contradiction verdict. This sounds like the real gatekeeper.
It absolutely is. It's the ultimate precision test. The judge checks if anything in the model's response contradicts the rubric, common knowledge, or the image itself. Even one tiny mistake, one hallucinated detail, and the whole thing fails.
They have that great example in Table 2 with the mural. The model got 100% on coverage. It identified everything important, but it still failed.
It failed because of the artist's signature. The ground truth said the signature was black text below the mural. The model said it was small white text in the bottom right corner of the blue mural.
A tiny difference in color and location.
And that's it. Response failed, marked as inaccurate.
Okay, but I have to push back on this for a second. Is that not maybe a little too harsh? I get the need for accuracy, but if you fail an otherwise comprehensive answer because of a tiny detail about a signature, are you not penalizing thoroughness?
That is a completely fair question, and it really gets at the philosophical trade-off that the researchers are forcing us to confront. Their argument is that for mission-critical uses, think medical diagnostics from an image, you can't tolerate any contradictions.
Okay, in that context, I see it.
If you let a model get away with mixing true facts with made-up details, you completely erode user trust. So they're choosing absolute, uncompromising precision over a kind of flawed comprehensiveness.
And that choice is reflected in the different model styles, right? Table 3 shows the Gemini models are more recall-oriented. They get higher coverage scores. They try to give you everything.
Whereas the GPT models are more precision-oriented. They score highest on no contradiction. It shows a real split in research strategy. Are you building a model to find every possible fact, or are you building it so that every fact it gives you is perfect?
And this leaderboard makes that tension crystal clear. Plus, the automated judge is solid. A Spearman's correlation of 0.64 and a macro F1 of 78.2 against human graders is pretty reliable.
For sure. So, okay, let's switch gears. From multimodal, we go to something completely different, the second pillar, FACTS parametric.
This is pure memory. No context, no tools, just the model and what's stored in its parameters. A closed book exam.
And they made this exam incredibly hard. The questions are about topics people search for, but they specifically picked the least common questions within those topics. So the models can't just rely on facts they've seen a million times during training.
It's all about digging for that deep, stable knowledge, the stuff that should be baked in. And the answers have to be verifiable on Wikipedia and be a single atomic fact. A name, a date, a number. No essays.
But the coolest part is how they curated the test set. They used an adversarial method. They took 5 really strong open-weight models and had them answer a huge pool of questions. Then they only kept the questions that every single one of those 5 models got wrong.
That's brilliant. So you're left with a test set that is guaranteed to be difficult, even for the best models out there.
It's a benchmark designed to find the breaking point, which is exactly what you need to push the field forward. And this brings us to the metrics, because it's not just about right or wrong, it's about accuracy versus the hedging rate.
The hedging rate,
right?
Just the percentage of time the model says, I don't know, or something similar, right?
It's about knowing what you don't know. And this is such an important question for you as a user. Do you want an AI that guesses confidently or one that admits when it's not sure?
Oh, for me, it's no contest. If I'm looking up a critical piece of data, like a financial figure, I would much rather it tell me it's not sure than to just invent a number.
Right. And Table 6 shows why this matters. GPT-03 actually has a higher raw accuracy, 57% versus 55.7% for GPT-5.
So on paper, it looks slightly better.
But then you look at hedging. GPT-5 is way more cautious. It hedges 13.3% of the time. GPT-03 almost never does, only 1.9%.
So GPT-5 is better at knowing its own limits. And when you look at the attempted accuracy, the score on only the questions it actually tried to answer, it's much higher.
Jumps up to 64.3% versus 58.2%. The benchmark rewards models for being cautious, for not overstating their confidence, and for anyone building high-stakes applications, that's a feature, not a bug.
Absolutely. So from pure memory, we move to the opposite, using tools. This is the third pillar, FCTS search.
Right. And the challenge here isn't just, can you use a search engine? It's about crafting queries that are basically impossible for a model without search. They focus on 2 things. Tail entities and multi-hop queries.
Tail entities being those super obscure facts, right?
Things that are just so rare they'd never be properly memorized. Like, what was the name of the ship that discovered the South Sandwich Islands in 1775? A closed book model would just hallucinate.
And multi-hop queries are even more complex. You have to chain searches together. The example of finding the birthplace of Yoko Ono's spouse instead of just John Lennon is a great one. You have to do one search to figure out who the spouse is, then another for the birthplace.
And they have 4 different subsets of this, from a hardtail set to these complex KG hops that are almost like database queries. It's really comprehensive.
And the key thing is that every model uses the same tool, the Brave Search API. So you're not testing the search engine, you're testing the model's strategy for using it.
And that gives us a really cool insight from Table 8. Gemini 3 Pro, the overall winner, is also the most efficient. It only uses about 3.39 searches per query on average. The Grok models search way more often.
So the best model isn't just finding the right answer, it's getting there with fewer steps. That's a measure of efficiency we don't often see.
And it matters for things like cost and latency in a real product. It's a critical engineering detail.
Okay, so that brings us to the final piece of the puzzle. XETS Grounding V2. This is all about long-form answers, summaries, Q&A, and making sure they stay true to a document you provide.
This is the updated version. They're now using a stronger panel of judge models, Gemini 2.5 Flash and GPT-5, which makes the evaluation more reliable.
But the big change is what they call the ineligible response problem. And I love this because we've all seen models do this.
It's a classic way models can sort of hack the benchmark. They give you an answer that's incredibly short and vague. It's technically 100% accurate and grounded in the document, but it's also completely useless.
It's like asking what were the key findings of this report.
Yeah.
And the model answers, the report contained findings.
Exactly. It's true, it's grounded, but it completely sidesteps what you actually asked for. And in the old benchmarks, that would have gotten a perfect score.
So what's the fix in version 2?
It's simple, but really smart. They added another LM judge. Its only job is to decide if the response is eligible, if it actually answers the user's question in a helpful way.
So if the answer is grounded but useless, it gets disqualified.
It gets marked as inaccurate. It forces the models to be both faithful to the context and comprehensive enough to be useful. You have to hit that sweet spot.
That feels like such a necessary addition. It moves the goalposts from just being technically correct to being genuinely helpful.
And that really ties all 4 pillars together. You've got multimodal integration, parametric recall, efficient search, and now this truly useful grounded generation. It shows just how many things have to go right for an LLM to be considered factual.
So that's 68.8% score. It's not really a failing grade for the models. It's more like a sign of success for the benchmark itself.
Yeah.
It's proving that you can't just scale your way out of this problem. You need dedicated research in all 4 of these areas at once.
It's the new roadmap, really. It shows how hard building trustworthy AI actually is. And, the paper even points out that this is still an incomplete picture. They've defined the state of the art for stable knowledge.
Stable knowledge, so facts that don't change or facts that are anchored to a document. But what about everything else?
Precisely. They mention things like video understanding or using specialized tools like knowledge bases or, the big one, handling fast-changing dynamic information. So this brings us to the final thought I want to leave you with. Given that this whole leaderboard is built around facts that are pretty stable, how do we even begin to design the next generation of benchmarks? How do we reliably test a model's ability to handle facts that are changing by the minute, by the second? That jump from static reliability to dynamic veracity, that feels like the next great frontier for this field.